Hello and welcome to another YouTube clip. Today's one is on Pythagoras and trigonometric ratios. So, here we've got a question that's going to use both Pythagoras and trigonometric ratios. And it is important to note you need to read the questions properly. So, this says, this diagram shows the cross-section of a hill on a BMX track. Sections A, B and CD are straight line segments. So that's just saying that AB, which is this bit up here, is straight, and CD, which is this bit over here, is also straight. Line AD is horizontal, BF and CE are vertical. Okay, so that automatically means that we have two right-angled triangles right over here. Calculate the distance between A and B in meters. Right, we need meters. It is really important that if it asks you for a particular unit, you give it to them. So, what have we got? We want AB, so we want this line here. Okay. Now, when using Pythagoras' theorem, if you want, you can write A, B, and C to label your sides of the triangle. So, we have C squared is equal to A squared plus B squared. Feel free to start that off. You don't have to write that in your assessment, but if you're a bit lost on where to go, it's always great to start off with your equation. So, we don't know what C squared is, but we do know what C is. So, C is AB. So, we can say the line AB, and if that ends up squared, then it's the same. Then it would be the same as C squared. So, we can put that there. So, A squared would be 9 squared, and B squared would be 6 squared. Okay, which should be 117. Okay, so all we have to do is square root AB. If we square root the square of AB, this should equal AB. So if that's the case, then what we do to one side of the equation, we must do to the other side. So that means AB would equal the square root of 117, which is 10.8166 blah blah blah. Okay, we're going to round that, so it's going to end up being 10.82 meters. You can put M for meters, and you must write how you've rounded it. So in this case, I've done it to 2 decimal places. 2 decimal places. Okay. Now, is that going to be okay? They have rounded a number over here, and they've got 6.5. So, ideally, round it to however they've rounded it. If they've used 1 decimal place, then you should be using 1 decimal place. So let's just round that again, shall we? So AB is equal to 10.8 meters, 1 dp. Now it's important to note when you're rounding, use a cutoff point. So, for example, back here where we've got all these numbers, and before we round it to 2 decimal places, we cut it off after the second number. And then we look at the number afterwards as you can see, and we think to ourselves, is it 5 or more? Yes or no? In this case it's yes, so we round our last number up, which is why it's 10.82. If it was 4 and less, then we would leave it at 1. So for example, again, we've rounded 10.82 to 1 decimal place. So we want that 1 number after the decimal place. We draw a line. Now the number after the 8 is 4 or less. So in this case it's 2, so it's less than 5. So that's why we leave the number at 8. Okay. Now, if the question specifies what to round it to, you do as the question asks. I've seen a lot of people think that it's okay to just round to 2 decimal places every time, and that is not the case. You need to read the question carefully. Okay. So, let's move on to the next one, shall we? I'll just erase all of this, so we've got the space. So, downhill sections of the track are given a risk factor as shown on this table. Use trigonometry to determine the risk factor for the downhill section from C to D. Okay, so that means we want this angle here. Whoops, let's change that back. So we want this angle in here. Okay, so let's label our triangle, shall we? Step 0, label our triangle. So the side opposite our hypotenuse, our right angle is our hypotenuse. Now, this is our angle that we are interested in. So, if that's the case, this makes CE our opposite side. So, we've got SOHCAHTOA. We've got our O, we've got our H, which is this one. So, we want our sine rule. So sine of an angle, so let's say sine of CDE, let's put angle sign there, is equal to the opposite over the hypotenuse, which in this case is 5 meters over 6.5. So remember, to find the angle, we must inverse this. We must do an inverse sine function. So, angle CDE is equal to inverse sine 5 over 6.5. Okay. Just going to pause this to use a calculator. Okay, which should equal 50.28 blah 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 degrees, which when we round it to 1 decimal place, it should be 50. Now remember, we draw our line in here. We only want 1 decimal place. The number after the line is larger than 4, so it's 5 and higher. So that makes 8, so we round it up. So 0.2 becomes 0.3 degrees. Bracket 1 dp for 1 decimal place. Okay. Now, when you're using your calculator, make sure it is in degree mode in this. Not radians or anything else. Make sure it is in degree mode. Okay. So, let's see. We have 50.3 degrees. That is 50 to less than 60. Here we go. So that's what we want. That is a high risk factor. So 50.3 is just above 50 degrees, but it's less than 60 degrees. So our risk factor is high. So, we haven't actually finished answering our question. We've given the angle, but it actually says here, use trigonometry to determine the risk factor for the downhill section from C to D. So you actually need to say here, 50.3 degrees is greater than 50 and less than 60. Therefore, that's what these dots mean. Therefore, you can write therefore if you want, or you can write the word so. I like using my therefore symbols because it uses a bit less space. So, therefore, risk factor is high. Okay. And that's the end of this example.